Hello guys and welcome to another video. We've already covered solving quadratic equations using the formula and factorization, but there's another method that's very useful, and it's called completing the square. Using this method, not only can you solve a quadratic equation using the completing the square method to find the x values, but you can also use the same method to derive and be able to prove the quadratic formula, which is very useful for understanding it and being able to mathematically prove how this formula works. When completing the square, your objective is to turn this general format that we could have seen before into the following: x plus p squared equals to q. Then you can do x plus p is equal to plus minus square root of q, and x is equal to negative p plus minus square root of q. This is what you want to find to isolate the x value. Let's practice this using one example. X squared plus 6x minus 7 is equal to 0. What you first must do is move the constant to the other side. X squared plus 6x equals negative 7 to the other side, positive 7. Now, you must add in both sides of the equation the coefficient of x divided by 2 and squared. So, x squared plus 6x plus 6 over 2 squared is equal to 7 plus what you must do on one side, you must do on the other side for it to be equal, 6 over 2 squared. This will give us x squared plus 6x plus 6 over 2 is 3. 3 squared is 9. 9 equals to 7 plus the same thing. So 9, 7 plus 9, 16. Now we can apply factorization to solve this that we have seen in a previous video. This we can say it is x plus 3 squared, as x times x is x squared. X times 3 times 2 is 6x, and 3 times 3 is 9. And we equal this to 16. Passing the square to the other side, we obtain x plus 3 is equal to plus minus square root of 16, which is plus minus 4. So x is equal to plus minus 4 minus 3. x1 can be equal to plus 4 minus 3, 1, and x2 can be equal to minus 4 minus 3, minus 7. These are our two values for x that work in this equation over here. Now, this method is not typically used to solve problems, but it is more typically used to derive the quadratic formula, to find this formula mathematically. Minus b plus minus discriminant b squared minus 4ac divided by 2a. So how do you go from this, ax squared, our general format? How do you go from this to that? So let's just use applying the square. What you must first do is divide everything by a to get rid of this coefficient. So a divided by a is just cancelled, so this stays like so. X squared plus bx over a plus c over a. Now you move the constant to the other side. X squared plus bx over a is equal to c over a. Or sorry, negative c over a. Now you add on both sides half and squared of this constant. So x squared plus b a x plus 1/2 times ba is just b divided by 2a, and all this squared equal to minus c over a plus b by 2a, and all this squared as well. we obtain that x squared plus b ax plus b squared over, you also have to square the numerator and the denominator, so 2 squared is 4, and a squared is a squared. This being equal to minus c over a plus the same thing that we obtained here, b squared over 4a squared. So now how do we move on from here? Well, we factorize this side. X squared, we can see that, x plus b over 2a squared is the same thing as this right here. And this is equal to minus c over a plus b squared over 4a squared. Now let's pass the squared to the other side as a square root. X plus b over 2a is equal to square root of minus c over a plus b squared over 4a squared. Now we must transform this that is inside a square root into a single fraction. And we do this by multiplying both the denominator and the numerator, as we know that we can do, by 4a. We multiplied this by 4a, and we multiplied that by 4a. And we obtain x plus b over 2a is equal to minus 4ac divided by 4a squared plus b squared divided by 4a squared. All this inside of a square root. Now we start seeing some similarities here. This is our discriminant for the formula. So we can say x plus b over 2a is equal to square root of our discriminant, b squared, as is the both same denominator. So we can add these two fractions divided by 4ac divided by application of the square root is that if you have a square root of a fraction, it is a square root of the numerator divided by the square root of the denominator. And the square root of 4a squared is the same as square root of 4, 2, square root of a squared. You just cancel these two, is a. So, divided by 2a. So, now that we have this, all we have to do is isolate this x by passing this to the other side as a negative. X is equal to minus b over 2a plus, plus minus, as it's a square root, b squared minus 4ac over 2a. Since these are both the same denominators, we can add these fractions. X is equal to minus b plus minus square root of b squared minus 4ac, all of this divided by 2a. And there we have it. We have gone from this general format, x squared plus bx plus c equals 0, into this formula right here, proving how this exactly works. Completing the square is a powerful tool for solving quadratic equations, but you will more commonly be asked for to prove the quadratic equation, and then you can apply this method. Thank you for watching, and I hope this video was of any help.